Okay, Bismillah. Okay, folks, welcome back. The following video will be conducted by myself, Mr. Imran Iqbal. Okay, on Imran Iqbal one-to-one tutor on YouTube. So today we're looking at GCSE topics. We're looking at more similar area questions. So in the previous videos we looked at similar lengths, areas and volumes. But now we're going to be looking at the advanced ones where you're going to have to use the square root sign. So these are the area questions I gave to my students for homework. So this particular video is being put up to help my students if they get stuck on their homework. Right, let's get started. So look at this first question here. We have a trapezium. It has an area of A. We have an enlarged trapezium, an area of 27 centimeters squared. The original length is 8 centimeters and the enlarged length is 12. So what we need to do first of all before we work out this original area is to establish the scale factor. So we look at this original length and this enlarged length. And we say, how does 8 become 12? Well, it becomes 12 by multiplying by the scale factor. So 8 multiplied by the scale factor is equal to 12, because the length of the original times by the scale factor equals the length of the enlarged. That's the rule that we've been using in all the previous videos. So, looking at the original length, looking at the enlarged length to work out the scale factor. Now, if I want to work out the scale factor, I've got 8 times by the scale factor is 12. Opposite times by 8 is divide by 8. So the scale factor is equal to 12 divided by 8. How many 8s go into 12, folks? 8 will go into 12 once with a remainder of 4. So we can establish from the lengths that in this particular area question that the scale factor is 1.5. Now we're going to need to use this 1.5 scale factor to work out the area now. So let's change color. Okay, now we know that the area formula is as follows. The area of the original times by the scale factor. Excuse me, folks. What is that? Okay, area of the time by the scale factor, area of the original time by the scale factor squared equals area of the enlarged. Area original, area enlarged. Okay, now that's our formula. Now, AO is AO. The scale factor we worked out to 1.5. And then we have AE. And AE is 27. Okay, right. We need to use a calculator. If you want to work out the AO, in this one, okay, we have to move the multiply by 1.5 squared over. So divide by 1.5 squared. So the AO is equal to, so we have 27 divided by 1.5 squared equals 12. Okay, now this first question that we just completed here, we got to AO is 12 centimeters squared. Okay, this particular question is similar to the previous questions. The advanced questions actually start in the next 3 questions. So let's have a look at those now. Okay. In this particular question here, question number 7, we have 2 similar triangles. The area of the first one, I'm going to call that A original. And this is the A enlarged. Okay, so we need to work out the enlarged length. Now in this particular question, we are starting with the areas, corresponding areas. So let's write down the formula that connects these two. Okay. Right. So we have here the area of the original times by the scale factor squared is equal to area of the enlarged. Remember, because we deal with area, it's got to be scale factor squared. So we know 5 is here. Time by the scale factor squared is equal to 20, the area enlarged. So we're going to work at the scale factor. Now, in this particular, this is why this particular video has got the title More Similar Area Advanced, because we're dealing with these kind of questions where you have to do a square rooting first. So to work out the scale factor is being squared and then times by 5. So you move the last action first. Time by 5 becomes a divide by 5. So 20 divided by 5 becomes 4. So the scale factor squared is equal to 4. We don't want the scale factor squared, we want the scale factor on its own. So we grab the squared, we take that over, becomes the square root. So the scale factor is equal to the root of 4, which I'm over here now. Okay, root of 4, so that will give us an answer of 2. So now we know that the scale factor is 2. So this is length original, time by the scale factor will give us this length here, length enlarged. So 4 times by 2 is equal to x is equal to 8 centimeters. Done. Okay. Let's look at the next question quickly. Question number 8. We have 4 centimeters squared, okay, and 36 centimeters squared. That's our original area. This is our enlarged area. Similar shapes. So now we need to work out the scale factor, not from the lengths, because we don't have enough information on the lengths. We have to work out the scale factor from the area information and then work out the missing enlarged length. So let's start again. So area of original time by the scale factor squared is equal to the area enlarged. So let's put some values in. So the area original is 4. And the area enlarged is 36. Okay. Now we're going to look at the scale factor. We know the area original, we know the area enlarged. Scale factor is being squared first and then times by 4. So when we make scale factor the subject, we move the last action first. So opposite time by 4 is divide by 4. So the scale factor squared is equal to 9. And then what we're going to do, we're going to have to get rid of the square. Opposite squaring is square rooting. So the scale factor is then going to be equal to 3. Okay. Mathematically, when you square root a number, we get two answers, a positive answer and a negative answer. So we actually that generates plus and minus 3. But for the sake of this particular question, we're going to be looking at the positive value only, plus 3. Okay, that one's done. Right, and the next one down is the question for you to do, folks. We have 4 centimeters squared rectangle becomes a 9 centimeters squared rectangle. The original length is 3. You've got to work out the enlarged length. Okay, folks, I hope this video has helped you, especially with these scale factor squared questions and how we deal with that. In the next video, we'll be looking at more similar volume advanced, where you have to do opposite of cubing is cube rooting. Please come back and join us in that. Thank you.